right, so yesterday we talked about component form, right? And we said, so if I write a vector v in component form, right? Basically what I have is I have the x component in here and the y component in here, right? So that's what we did yesterday. The day before, we learned two additional things. We learned that the x component was actually v cosine theta, you remember? And the y component was actually how much? V sine theta. So now we're sort of going to combine them and we're going to put that inside our brackets, okay? So remember, I have these here again. X is v cosine theta and y is v sine theta. That's always the case. And if we're writing v in component form like this, okay, then I could just do v cosine theta, v sine theta, and put that in my component form. All right? So let's start with an example here. Take a look at this one. So it says find the component form, so like this, of the vector v with magnitude 7 and direction angle 60. Okay? Magnitude 7, direction angle 60. So basically, v is that, and that's that. So what I want here, I want to put x and y, right? But I have v and theta. So I have v and theta, and I want x and y. So what I'm going to do is find x and y first. So I say, okay, x is equal to v cosine theta. So that's 7 cosine 60. Okay? And what's the cosine of 60? Do you guys remember? It's actually a half. So the x component is 3.5. Now I'm going to do the same thing with the y. Y is v sine theta. So that's going to be 7 sine 60. And that was, sine 60 was root 3 over 2. So why don't you put that in your calculator and tell me how much this y component is. Go ahead and take out your calculators. All right, so that's 6.1. So now, remember how we had to write it in component form? So I say vector v is equal to the vector brackets, and inside I'm going to put my x and my y. Okay? So that's how you find component form if you've got magnitude and the angle. Okay? All right, now, how to find direction of an angle? If you're given the vector in component form, like v equals a comma b, then to find the angle, you have to take the tangent between the two of them. All right, the tangent of two of them. Why? Okay, so suppose v is equal to 5 comma 9. Right? How does that look if you graph it? You go 5 in the x and then 9 in the y. Right? And that looks like that. Yes? So now, what I want to find is this angle here. Well, how do I do it? Look, there is a y component of 9, and then there is an x component of 5, right? Opposite and adjacent, that looks like tangent, right? So tangent of theta is 9 over 5, which is x. Oh, I have it wrong here. It's y over x. Sorry, guys. Y over x. Okay. All right. So here it says find the direction angle. for the direction angle, it's always tangent of theta equal to the y over the x. So 9/2. And now if that's tangent of theta, how do I find theta? What do I do?
Inverse.
Inverse tangent. Good. So theta is inverse tangent of 9/2. 77.5, yeah. Okay. Does that make sense? So if I go 2 across and 9 up, does that make sense that that angle is 77.5? It does, right? That's a rather large angle. Okay. All right, let's talk about resultant speed. So remember how we said to get the resultant vector, we add the two vectors, right? So we're going to do the same thing and add two vectors here. All right, so take a look. To find resultant, magnitude, and direction. Look at this one. I'm going to walk you through this example just like I did like with multiplying matrices, you guys remember? And then, but after that, you're not going to have all these like steps laid out for you anymore. Okay, so vector A has a magnitude of 10. I like to color code them. And makes an angle of 25 with the horizontal. All right, so vector A has a magnitude of 10 and makes an angle of 25 with the horizontal. Vector B has a magnitude of 5 and makes an angle of 30 with the horizontal. Our first step, okay, so we have to find the magnitude and direction of the resultant vector, right? We have to find magnitude and direction. So you have to go in steps. There are 3 steps to do it. Well, 5 steps to do it. Okay, so step 1 is we have to draw the resultant vector R. Remember how we did resultant vector? It was like that handout that you did with, you were given the vectors, you put one after the other, and then you drew the resultant. That's what we're going to do. So let's draw the red vector. A has a magnitude of 10 and an angle of 25 with the horizontal. So if I draw an imaginary horizontal line, A has a magnitude of 10 and it makes an angle of 25 with the horizontal. Does that look like a good approximation, right? Okay. B has a magnitude of 5 and makes an angle of 30 with the horizontal. Let me just draw B separately on its own. If this is an imaginary horizontal line, it's got a magnitude of 5, so shorter than that one, and it makes an angle of 30 degrees. Does that look like a good approximation for B? Maybe a little bit bigger if we were to scale it. Okay, now what I want to do is I want to find the resultant of these things. So what I need to do is I need to take B and I need to put it as a continuation of A, right? So why don't we do that? I'm just going to take that whole setup here and move it over. So it's like, that's the horizontal line, 30 degrees, and it's got a magnitude of 5. Now, how is the resultant going to look? It's going to go from where to where? From the beginning of the red to the end of the blue, right? So the resultant is going to go that way. So that's what I mean when I say draw the resultant. Okay. So now it says, now we have to write A and B in component form. So let's work on vector A, right? How do I put it in component form? What's the x component of A? So the x component of A is 10 cosine 25, right? And what's the y component of A? 10 sine 25. So go ahead and put those in your calculator and write them down, and then we'll go from there. All right, so this is what we got for x and y components, right? So I say vector A is equal to 9.1, comma 4.2. Now what you're going to do is you're going to do the same thing for vector B. All right, so I'm going to give you a minute to do the same thing for vector B. On your mark, get set, go. I'll pause this for a minute. So for those, we got 4.3 and 2.5. So I'm going to put my vector B over here, and it's going to be 4.3 and 2.5. Okay? Now, this whole thing is because we want to find this resultant R, right? And what did we say R was? R resultant means adding two vectors, right? So now I'm going to add my two vectors, 9.1, comma 4.2 plus 4.3, comma 2.5. And now that we're experts at adding vectors, I can add those two vectors and I could get that my R vector is how much? 13.4 and how much? 6.7. Whoops, not parentheses, brackets. Okay, does that make sense? Take a look at it. If you've drawn your diagram pretty much to scale, which I feel like we did a good job. Hey. Does it make sense to draw vector R? I would have to go 13 units horizontally and about 6.7 vertically. That kind of makes sense, right? Like if you look at the scale of it, yeah? So it looks like, okay, we're on the right track. So that's vector R. Now what I need to do is I need to find the magnitude of vector R. Do you remember how we were finding magnitude yesterday? It was this, a squared plus b squared. So why don't we do that? To find the magnitude of vector R, I'm going to do the square root of 13.4 squared plus 6.7 squared. And I would like you to be able to put all that in the calculator in one shot, right? And when we do that, what do we get? Anybody? So it's 14.98. We're almost there. Let's go back and see what is it that we were looking for. We needed the magnitude of R and we need the direction of R. Here we found magnitude. Now to do direction, I have to do, it's y over x again. I have to do inverse tangent of y over x. So tangent of theta is equal to 6.7 over 13.4. So theta is inverse tangent of all of that. All right. And Darrell, you're going to tell us how much that is. So we get 26.6 degrees for the direction. Now, let's think again. Does my answer make sense? Look at vector R. Does it make sense that that's like 26 degrees from the horizontal? It kind of does, right? So we're good. We're on the right track. Okay, so we're going to do another one. All of this, but I haven't laid out the steps for you because in reality, we don't have the steps laid out for us. So let's do it again. Take a look at this one. There's a, yeah. All right, there's a soccer player running forward at 7 meters per second, okay? He kicks a ball with a velocity of 30 meters per second at an angle of 10 degrees. What is the resultant speed and direction of the kick or of the ball, right? How is the ball gonna fly? Okay, so let's draw these two vectors. I'm gonna call the soccer player vector P, and I'm going to make the ball vector B. Okay? All right, so the soccer player is running forward. That means he's running, is he running at an angle or is he running horizontally or vertically? He's going horizontally, right? So here he is. That's P, and he's going at 7 meters per second. Okay, that's just him. All right. Now, he kicks the ball, right? He kicks the ball at a velocity of 30 meters per second at an angle of 10 degrees with the horizontal. So I'm going to draw that as a continuation of this, right? So if this is an imaginary horizontal line, he kicks it at 30 meters per second at 10 degrees. So something like that. Okay? Now I'm going to draw my resultant. Okay? Alrighty. Okay. Now, I need the resultant speed and direction of the ball or of the kick. Okay, so what we're going to do is, what did we do here? Put each vector in component form. So look at this one. Because this is all horizontal, it's easier for me to put it in component form, right? So what would that be in component form? Everything is in the horizontal direction, 7, and there is nothing in the vertical direction. So it's 7, 0. So that's the simplest case ever. How am I going to do B? Anytime it's diagonal, you got to do B cosine theta, B sine theta. Okay? So for B, the x component for B is equal to 10 cosine, 30 cosine 10. And the y component, 30 sine 10. All right, so go ahead and tell me how much those make. All right, so we've got 29.5 and 5.2. So vector B is that much. Okay, now, how do I write vector R? You have to add them. Good. So it's 7 plus 29.5, 0 plus 5.2. 36.5, 5.2. All right, are we done?
No.
Because we want magnitude and direction. All right, so let's do magnitude. Okay. We get 36.9. What are the units? Meters per second. How am I going to do direction, theta? You could do like in one shot, that's the inverse tangent of 5.2 over 36.5. Same numbers as you used here. Right? So what does that give you? 8.1? .1 degrees. So what does that mean? The guy was running at 7 meters per second. Okay? He kicked the ball at 30 meters per second. Now the ball is flying at 36.9 meters per second. at an angle of, yep, 8.1 degrees. So he kicked the ball at 30 meters per second. If he was not running while he kicked it, the ball would just keep flying at 30 meters per second. But the fact that he was running while he kicked it, now the ball has an added velocity, so it's going faster at 30 meters per second, at 36 meters per second. Also, he kicked it at 10 degrees. Again, if he was just standing still and he kicked it, the ball would just keep flying at 10 degrees. But because he was also going forward, right, now that added to it, so instead of going at 10 degrees, it's going at 8.6 degrees. It flattened out a little bit, right? So all of that, and the next time you're watching soccer, keep that in mind.